Welcome learners to our channel. In this video, we are going to have a comprehensive revision of key topics in integrated science, including rusting, metals and non-metals, hard and soft water, atoms, elements and compounds, pressure, diffusion, alloys, magnetism, the skin and the parts of the skin, energy, acid, bases and indicators, photosynthesis and the periodic table, and even the simple circuit. This paper is designed to reinforce understanding and support of exam preparation, and each concept is clearly designed and connected across all the branches of science. The first question, grade 9 learners were discussing different ways of preventing rusting, and the following answers were suggested. Which one was incorrect? So in this case, we are supposed to identify a method which is not a way of preventing rusting. But before we discuss or we look at the options given, let's first look at what is rusting. Rusting is defined as a process where iron metal react with oxygen and water to produce a brown substance which we call rust, and the chemical name of rust is hydrated iron 3 oxide. Now, for this process to take place, there must be conditions which must be met, and the first condition is that there must be iron metal. Then the second one, there must be water, and then finally there must be oxygen gas. However, this process can even take place faster if we have conditions like acidic condition, salty condition, and high temperature. Now let's look at these options given and identify the one which cannot be used to prevent rusting. So in this case, the first option is cleaning and drying. Cleaning and drying, you cannot prevent water and oxygen from getting in contact. So in this case, this one cannot prevent rusting. Then the second option that we have is galvanization. Galvanization is defined as a process in which iron metal or steel is coated with a thin layer of zinc, and this zinc will react with water and oxygen to form zinc oxide coating that does not rust. So in this case, if you include another metal here which will prevent iron from rusting, like in this case galvanization, then galvanization can prevent rusting. Number C is making alloys. Alloys, this is a mixture of two or more metals. So in this case, if you mix iron with another metal which cannot rust, in this case you can prevent rusting. And then the D is oiling and greasing. Oiling and greasing can prevent water and oxygen from penetrating to get in contact with iron. So in this case, oiling and greasing is also a method of preventing rusting. Therefore, our option here, the one which is incorrect, is cleaning and drying. This one cannot prevent rusting. So another thing that you should note is that we have other methods which we can use to prevent rusting, and one of it is what we call electroplating. Then another one which we can use is sacrificial protection. We have what we call sacrificial protection. You can go and look at or do research on the same. Another one which we have is painting. You can do what we call painting. And then of course we have what we call plastic coating. You can have all these methods. They can be used to prevent rusting apart from galvanizing, making alloys, and oiling and greasing. The second question, which among the following elements are non-metallic? So in this case, we have metals, but there is one which is non-metallic. And now we are required to identify the one which is non-metallic. Mercury is a metal, but it's in liquid state. It's a metal which is in liquid state. So mercury is the only metal in liquid state. The second one is magnesium. Magnesium is among the first 20 elements, and it's atomic number 12. So if we can write its electron arrangement is 282. Therefore, in this case, magnesium is a metal because it has less than 4 electrons in the outermost energy level. In this case, it has 2. So this one is a metal. This is a metal also. Beryllium is atomic number 4. Atomic number 4. Electron arrangement of beryllium is 2, 2. So also in this case, it has 2 electrons in the outermost energy level, and any element with less than 4 electrons in the outermost energy level is a metal. Then let's look at number D. D is phosphorus, atomic number 15. Then the electron arrangement for phosphorus is 2, 8, 5. And in this case, it has 5 electrons in the outermost energy level. So, and we have said when it has less than 4 electrons, it's a metal. Therefore, when it has more than 4 electrons, like in this case 5, this one is a non-metal. So in this case, our option, a substance which is non-metallic, is phosphorus. The third question, Mr. Onsongo discussed with grade 9 learners about the minerals present in hard water. Which learner gave the correct answer? Which learner gave the correct answer? Before we look at the options, let's define hard water. Hard water is defined as water that contains dissolved minerals of calcium and magnesium ions. So for you to have hard water, that water must contain dissolved calcium and magnesium ions. Now let's look at a learner who gave the correct answer. Ocheng said calcium and manganese. These two are incorrect. Then Joyce said manganese and magnesium ion. So magnesium ion is correct, but manganese is not. Nauma said calcium, which is correct, and magnesium ions, this is correct. Then Tess said sodium salt, this is incorrect, and calcium is right. So in this case, the one who gave a set of minerals is Nauma, who said it is calcium and magnesium ion. So the correct answer is C. The fourth question, we can remove water hardness through the following except. So we have a set of methods of removing water hardness. Which one is not? The first one that we are given is A, filtration. Filtration cannot be used to remove substances that dissolve. Remember, we have said hard water is water that contains dissolved. So filtration is not, because the filtration only separates substances which cannot dissolve, like water and sand. So in this case, filtration is incorrect. Then the second one is simple distillation. Simple distillation is correct. You can use it to remove water hardness. Boiling can be used to remove water hardness, is correct. Use of sodium carbonate, sometimes we call this one washing soda. This one is also correct. So in this case, the one which is incorrect is filtration. Filtration cannot be used to separate substances which dissolves. Then question 5, which of the following is not a characteristic of hard water? Now in this case, we have a set of characteristics, and now we are required to identify the one which is not that of hard water. The first one is that hard water does not rather easily with soap. This one is correct. Then B, formation of white spots on glassware. This one is correct, because hard water forms white spots on glassware. The other one, number C, is brightening of clothes. This one is wrong. Hard water does not brighten clothes. It's only soft water which can do that. Then the last one, D, hard water has metallic taste. This one is correct. Hard water tastes metallic. So that this one is correct. So in this case, the correct option in this case, we are asked which one is not a characteristic of hard water, is that hard water brightens clothes. This one is a function or is a property of soft water. Question 6. Which among the following materials can be used as an insulator for electricity? So for a material to be used as an insulator, in this case it must be a poor conductor of electricity, and materials which are poor conductors of electricity are non-metals. So let's look at the set of the materials that we have and then identify the one which is a non-metal because it's a poor conductor of electricity. The first one, copper. Copper is a metal. Copper is a metal. Therefore, it's a conductor and it cannot be used as an insulator. The second one is aluminium. Aluminium is a metal, atomic number 13. It's a good conductor of electricity, therefore cannot be used as an insulator. Then the number C is rubber band, is a non-metal. It's a non-metal. It's a poor conductor. Therefore, in this case, it can be used as an insulator. Then D, we have steel wool. Steel is a metal. Steel is a metal. It's a good conductor and therefore cannot be used as an insulator. So the correct answer here, a material which can be used as an insulator is rubber band because it's a non-metal and therefore a poor conductor of electricity. Question 7. The smallest unit of an element that retains its chemical properties is. Before we answer this, let's define each of these particles that we have been given. The first one is a molecule. A molecule is defined as a group of atoms of similar or of the same or different elements which exists independently. Then an ion, we define it as a positively or negatively charged atom. So if you have an atom, you charge it positively or negatively. When you charge it positively, it means you take an electron out of it. It remains to be a cation. When you charge it negatively, you add an electron to it. It forms an anion. Therefore, in this case, it forms what we call an ion. Then C, a compound. A compound is defined as a pure substance. Made up of two or more elements. Chemically combined. And then finally, we define an atom as the smallest particle of an element, which cannot be split into any simpler mean by any chemical process, by any chemical reaction or process, and it carries the chemical identity of the element. Therefore, in this case, the smallest unit of an element that retains or that carries the chemical properties of the element is an atom. So the correct answer is an atom. Question 8. The following are different changes in a substance. Which among them shows a temporary change in a substance? A temporary change is a change which you can reverse and that there is no new substance which is formed. Let's look at option A. Burning wood into charcoal. This one you cannot reverse because you cannot reverse charcoal back to wood. So that one is not a temporary change. B. A nail undergoing rusting. Rusting is a chemical process where iron reacts with oxygen and water to form rust, or what we call hydrated iron 3 oxide. So this one is a chemical process. It can never be a temporary change. C. Melting a candle. Melting is a temporary process because a candle is in solid state. When you melt it, it changes to liquid state, and then when you cool it, it changes back to solid state. So this one is a temporary change. Then D. Burning a newspaper. This one you cannot reverse. Therefore, the correct answer here is melting a candle. Question 9. In which of the following situations will a person exert greatest pressure on the ground? Before we answer this question, let's define pressure. Pressure is defined as a force acting normally is 90 degrees, a force acting normally on a surface per unit area. So if we can write this one in a formula, then pressure, which is P, is going to be a force divided by area. So this means if area is small, then pressure is going to be high. If area is maximum or is more, then pressure is going to be low. So in this case, we are required to find greatest pressure. So for us to get greatest pressure greatest, then in this case we need a force, then you divide by area, which is small area. That's how you can get greatest pressure. But if you need smallest pressure you need a smaller one, then in this case you will take a force, then you divide by area, which is maximum or greatest area. So in this case now, in our case, we are required to use this one where we need the greatest pressure. So we'll look at a situation where the area in contact with the ground is small. So let's look at the first option. A, when lying down on the ground. When you lie down on the ground, the area in contact with the ground is maximum or is large. Therefore, this one cannot give a great pressure. So in this case, it gives a small pressure. Then B, when standing on toes. Remember, your toes have a very small area. So in this case, this one can give a maximum area. But let's look at the other options. When standing on one foot is larger than toes. So this one cannot. Then D, when on the 2 feet. When you are on the 2 feet, in this case, that is a very large area. It cannot. So in this case, when you are standing on toes have a very small area. You can look at your toes. So in this case, this is when you can exert greatest pressure. Remember, for you to exert greatest pressure, you must be in contact with the ground with the smallest area. Question 10. Which among the following is not a role of diffusion in living organisms? Diffusion, remember, is a process where particles move from a region of high concentration to a region of low concentration until an equilibrium is established. So in this case, which one of these is not a role of diffusion? So it means the 3 of them are roles of diffusion. Which one is not? Let's look at option A, carrying out the process of photosynthesis in plants. This one is not a role of diffusion because photosynthesis is a process where green plants make their own food using simple materials like water, carbon dioxide, and sunlight. So in this case, diffusion does not take any role in that case. B, gaseous exchange in human being. This one is a role of diffusion. Absorption of digested food. This one is a role of diffusion. Absorption of mineral salt in plants. This one is a role of diffusion. So in this case, the one which is not a role of diffusion is A, carrying out the process of photosynthesis in plants. Question 11. Which of the following statement about alloys is incorrect? So we have been given 4 statements here. 3 of them are correct statement about alloys. Which one is incorrect? So before we find out the one which is incorrect, let's define an alloy. An alloy is defined as a uniform mixture of 2 or more metals, or sometimes it can be non-metals. So it must be a metal with another metal, or a metal with a non-metal. And the reason why these 2 are mixed is to make it stronger, more resistant to corrosion, and even more ductile and durable. So in this case, now let's look at the option that we have been given. A, most alloys are resistant to corrosion. This is correct. It's even in the definition. So this one is correct. B, alloys are made up of 2 or more metals. This one is correct, and it's there in the definition the way we have defined it. C, alloys are harder and stronger than pure metals. This one is correct. Then D, alloys are softer, which makes them more useful than pure metals. Alloys are more strong and durable. So the one which is incorrect about alloys is D. But the first one, alloys are resistant to corrosion, that is correct. B, alloys are made up of 2 or more metals, that is correct. C, alloys are harder and stronger than pure metals, that is correct. So the one which is incorrect is D, which is alloys are softer. Alloys are not softer, they are hard. Question 12. A freely suspended bar magnet always aligns itself in which direction? So in this case, if you have a magnet and then you suspend it freely and you swing it, in what direction is it going to settle and why? This magnet will settle in a north-south direction, like you can see on the screen. And the reason why it settled in a north-south direction is because it aligns itself with the magnetic field of the Earth. Remember, the Earth acts like a giant magnet with a north pole and south pole. So it also has a magnetic field. So if you suspend a small magnet, it will swing and it will settle in a north-south direction in line with the Earth's magnetic field. So the first option we are given, east-west, this is wrong. North-south, this is correct. Up-down, no. Randomly, no. So the correct answer here is north-south because it aligns itself with the Earth's magnetic field. Question 13. The skin have layers that have different tasks. What is the function of the epidermis layer? Epidermis is the uppermost or the outermost layer of the skin. So let's look at the skin structure that we have here on the screen. On the upper side here, or the upper part, we have what we call an epidermis, and this epidermis contains cells that produce pigments and also protects the skin. The following layer, the layer that follows, is called the dermis. A dermis contains nerve endings, oil and sweat glands, and also hair follicles. And then on the lower part, we have another layer, which we call subcutaneous tissue, and this one is made up of fats and connective tissues and large blood vessels. So in this case, we are asked which one of these is a function of an epidermis. A, protects the skin against physical injuries. This is correct. That is exactly what we have seen. On the upper part of the skin, it protects the other part of the skin from physical injuries. Then B, storing fat. Fat is stored in the subcutaneous layer, so this one is not. Then producing sweat. Sweat is produced by sweat glands, which are found in the dermis. So this one here are found in the dermis. This one is found in subcutaneous layer. And then D, storing blood vessels. Blood vessels, all blood are stored. And D, storing blood. Blood is stored in blood vessels, so this one is not. So the correct answer in this case is protecting against physical injuries. The epidermis protects the skin from physical injuries. Question 14. Which of the following is a renewable source of energy? We define renewable sources of energy as natural resources that can be replaced naturally within a very short time, and they are essentially inexhaustible. So some of the examples of these renewable sources of energy that we have, one of it is things like solar energy. We have wind energy. These are natural and they cannot be exhausted. We have hydroelectric energy. We also have ocean waves energy. We have other things like biomass energy, and we have other sources like geothermal. Geothermal, remember, is the energy created from the Earth's internal heat, and therefore in this case Earth produces it in its interior part and it cannot be exhausted. So now we are asked which of these is a renewable. So let's look at the first option, A, coal. Coal is a non-renewable. B is natural gas. This is a non-renewable. C, geothermal. Geothermal we have listed here among the renewable sources, so this one is correct. D, petrol. Petrol is a non-renewable. So in this case, the one which is a renewable source is geothermal. And geothermal, we define it as a source of energy which is extracted from the Earth's internal heat. And in this case, Earth produces heat more often and it can never be exhausted. Then question 15, which of the following are applications of bases? Remember, bases, we define them as substances which react with acids to produce salt and water, or sometimes we define them at your level as substances which turns a red litmus paper to blue and the blue litmus paper remains blue. So now which of these is an application of a base? 1, vinegar and baking powder. Vinegar is an acid. This one is an acid which or is acidic. Baking powder is a base. So in this case, this set is not basically for bases. So it's wrong. B, lemon juice. This is an acid. This is an acid or is acidic. Then soap. This is basic or this is a base. So also this set is not purely for bases. C, toothpaste. This one is basic. And then baking powder, this one is also basic, so this set is correct. Then D, vinegar, this one is acidic. And then washing soda, this one is basic. So this set is also not purely for bases. So the correct answer here, the application of bases is C, in the manufacture of toothpaste and manufacture of baking powder. Section B, question 16A. Name two differences between metals and non-metals. So for us to answer this, because we are going to list many of them, let's draw a very small table here. So in this side, on the left side, we are going to have metals. And then on the right side, we are going to have non-metals. So for metals, the first difference is that metals are malleable. Metals are malleable. A malleable substance is a substance which you can hammer into a sheet without breaking, while non-metals are brittle. Non-metals are brittle. A brittle substance is a substance which, if you try to hammer it, it will break into pieces. So in this case, metals are malleable while non-metals are brittle. The second difference that we can give is that for metals, metals are ductile. Metals are ductile. A ductile substance is a substance which you can mold into a wire without breaking. Then, in this case, we can say for non-metals, non-metals are non-ductile. Non-metals are non-ductile. It means you cannot mold non-metals into a wire. Then another difference that we can list in this case, number 3, is that metals are good conductors of heat, while non-metals are poor conductors of heat. Then another difference, number 4, is that metals are good conductors of electricity, while non-metals are poor conductors of electricity. Then you can even give the fifth one is that metals are shiny, because most metals are gray in color while non-metals are dull. Then question B, list any two alloys and their compositions. So when you are told to list alloys and their compositions, remember we said an alloy is a mixture of two or more metals or sometimes a non-metal, and the purpose for mixing these metals is to make it stronger and more resistance from corrosion, and even make it more ductile, where you can mold it into a wire and so on. So in this case, you are told to list any two alloys and what they are composed of. We can list the three. In this case, the first one we can list is brass. Brass is an alloy made of copper and zinc. This is the first alloy. The second that we can list in this case is steel. Steel is made up of iron and carbon. Then the third one which we can list in this case is bronze. Bronze is an alloy made of copper and tin. So we have very many other alloys, but for this case, let's have this. Question 17. Explain two effects of impurities on boiling and melting points. So in this case, boiling point is a specific temperature at which a liquid changes to vapor, while a melting point is a specific temperature at which a solid changes to a liquid. Now, what are the effects of impurities on melting points and on boiling point? So we want to begin with the melting point, and we say the impurities lower the melting point. How do impurities lower the melting point? Impurities lower the melting point by disrupting the orderly. They disrupt the orderly arrangement. They disrupt the orderly arrangement of particles, hence weakening the force of attraction, between the solid particles, and in this case, the temperature which is required for melting now is lowered. So if you have an impurity in a solid state and you want it to change to a liquid state, impurities will lower the melting point. They lower the melting point because they interrupt the order arrangement of particles, and this one weakens the force of attraction between the solid particles, and in that case, the temperature which is required for that solid to melt will be lower. For example, if you have ice which has a melting point of 0 degrees Celsius, if you add impurities, it will melt at a temperature of about -5 before 0 is reached, because the force of attraction between the particles of ice particles is weakened. Then the effect of impurities on boiling point, in this case, the boiling point. They raise the boiling point. And how do they raise the boiling point? In this case, impurities reduces vapor pressure of a liquid. So in this case, we will say they reduce vapor pressure of the liquid. And if the vapor pressure of a liquid is reduced, in that case, its boiling point will be higher than the original or than the pure substance. So in this case, the two effects of impurities in boiling and melting point is that they lower the melting point and they raise the boiling point. Question 18. In a perfume shop, a customer sprayed a perfume on one side of the room, and within a few seconds, people on the other side could smell it. What process is responsible for the movement of the perfume molecules? So for perfume molecules to move, they must move from where they are highly concentrated to where they are lowly concentrated. So where this person sprayed the spray or the perfume, that is where the particles are highly concentrated, and where the people were, that is where it was lowly concentrated. So if they felt the smell after some time, then it means the particles moved from high concentration to low concentration, and that process, we call it diffusion. So it's diffusion which facilitates the movement of particles from where the perfume was sprayed to where the people were. Then question B, state two factors that affect the rate of this process. Remember, we have identified the process as diffusion. So factors which affect the rate of diffusion, one of it is concentration gradient. Concentration gradient. So in this case, if the gradient is great, then diffusion is very high. 2 is temperature. Temperature also affects the rate of diffusion. If the temperature is very high, diffusion is very fast. If the temperature is low, the particles move slow. Then another one is the size of the molecules. Size of the molecules involved. Size of the molecules. If the molecules are very large, then the rate of diffusion is low. And if the molecules are very small, then the rate of diffusion is very fast. Then another question, why does diffusion occur faster in gases but they occur slow in liquids? Let's look at the structure of liquids and gases. Gases are made up of particles which are very far away from each other and they are in random motion, while in liquids are made of particles. Of course, they are in random motion, but these particles are relatively close to each other. So in this case, the reason why diffusion takes place faster in gases is because the gas molecules are far from each other. In this case, you can say gas molecules are far from each other. Therefore, the force of attraction is weak, hence they move fast. Then the second one that you can say is that gases have a higher kinetic energy than liquids. So the two reasons why diffusion takes place in gases than in liquids is that in gases, the molecules of the gas are very far away from each other. Hence, in this case, the force of attraction is weak, so they can move easily. And then another reason is that gases have a higher or a greater kinetic energy than in liquids. Question 19. During a science lesson, a teacher drew a diagram of an atom on the board as shown below. The diagram had a nucleus and several particles orbiting it. So before we look at the questions, let's label these subatomic particles. A, this is an electron because it's found in the energy level. This is what we call energy levels. Energy levels. Then B is a neutron. This is a neutron because it's found in the nucleus. Then C is a proton. It's a proton because you can see it has been given a simple positive charge. So in this case, the inner part, this inner part here, where we have protons and neutrons, this is what we call a nucleus. This is a nucleus. So in this case, let's go to the questions. Name the 3 subatomic particles of an atom. The first subatomic particle of an atom is electron. The second subatomic particle is a proton. Then the third subatomic particle is a neutron. Then question B, which subatomic particle carries a negative charge? Which subatomic particle is negatively charged? Electrons, which are found in the energy levels, are the one which are negatively charged. So in this case, it's an electron. Then where in the atom are protons found? Where can you find protons in an atom? Look at C. C is found in what we have labeled as a nucleus. So in this case, protons are found in the nucleus. Protons are found in the nucleus. So that's where we found the protons. Question 20. During a nature walk, students collected different types of leaves and observed their internal structure under a microscope. Question A. Which internal structure of the leaf contains chlorophyll? The internal structure of the leaf that contains chlorophyll is called a chloroplast. A chloroplast is the internal part of the leaf which contains chlorophyll, which is used to trap light which can be used in photosynthesis. Question B, state two functions of the structure of the leaf. State two functions of the structure of the leaf. And in this case, we have several of them, but we're going to list a few. In this case, we have stomatas, which are used for gas exchange and also regulate water loss. Another function of the structure of the leaf is that they maintain internal balance. They maintain internal balance. Another role of the structure of the leaf that we can give is that they do what we call transpiration, and many other functions that you can list. Then another question is, what is the role of veins in a leaf? The role of veins in a leaf, one of it is that veins are used in transporting or in transport, and in this case they do transport in two ways. They have what we call these are xylem tissues, and these xylem tissues are used to transport water and mineral salts, and then at the same time, on the same transport, we have what we call a phloem. We have a phloem, and a phloem is used to transport food after it has been manufactured during photosynthesis. This phloem is used to transport food to other parts of the plant. Another function another role of veins in a leaf is that they give a leaf a structural support. They give structural support. So these are the two main functions of the leaf. One, they transport, and in transporting they have a xylem tissue which transports water and mineral salts from the soil to the leaf to the plant. Then we have a phloem which transports food from the site of photosynthesis to other parts of the body. And then another role of veins is that they give structural support. Question 21. A scientist examined electron arrangement of an element with atomic number 12. Then A, write electron configuration of this element. What is an electron configuration? This is the arrangement or the distribution of electrons in the energy levels of an element. So in this case, if you have an atom like this one, for example, this atomic number 12, it means the number of protons is 12. Then the first energy level, then we have the second energy level, we have another energy level for this case. Then the first energy level will take only 2 electrons and it is full. Second energy level will take 8, 1, 2, 3, 4, 5, 6, and then 7, 8. And then the last one now will take 2, so that now we have 2 plus 8 plus 2, that is 12. I want you to know that electrons are placed in pairs. Electrons are not placed as an individual. They must exist in pairs with a spin of half-half for it to make one. You will learn that in grade 10. So in this case, this is the energy level diagram with electrons distributed in different energy level. So electron configuration is the arrangement of these electrons in the energy levels of an atom of an element. Now in this case, how can we write the electron arrangement? We write the first energy level takes 2, then the second energy level will take 8, and then the third energy level will take the remaining 2. So that is the electron arrangement of this atomic number 12. Then B, which group of the periodic table does this element belong? We determine the group of the periodic table where this element belong by looking at the number of electrons in the outermost energy level. Like in this case, look at the substance that we have and then look at the outermost energy level. It has only 2 electrons. Therefore, it means if we have this as our electron arrangement 2, 8, then 2, then in this case it means this is the innermost energy level or the first energy level, this is the second energy level, then this is the outermost occupied energy level. So the number of electrons which are found there is equals to the group in which this element belong. So like in this case, the group in which this element belong is group 2. We write in Roman capital numbers. So it means in this case, if we could have an element with the electron arrangement 2, 8, 1, then in this case it could belong to group 1. If we could have an element with the electron arrangement 2, 8, 7, in this case its group will be group 7. You write in Roman numbers. Then if it's in 2, 5, in this case you look at the outermost energy level, then in this case it will be in group 5. But in our case here it was 282 where it belongs to group 2. Now question C, why is it classified as a metal? We classify substances as metals or non-metals by looking at the electrons in the outermost energy level. So if the electrons in the outermost energy level, let's call it X, if X is greater than 4, in this case, if the electrons in the outermost energy level is greater than 4, then it means in this case it's a non-metal. If the electrons are 5, 6, 7, it's a non-metal. Then if X, which is the number of electrons in the outermost energy level, is less than 4, that is, it means 1, 2, and 3, then in this case it is a metal. So now if we look at the case that we have up here, the number of electrons in the outermost energy level in the electron arrangement 2, 8, 2, this number of electrons in the outermost energy level is less than 4. Therefore, it means this one is a metal. So in this case, it's a metal because the number of electrons in the outermost energy level is below 4. So this one is a metal because the number of electrons that it has in the outermost energy level is less than 4. Question 22. Draw a well-labeled simple electric circuit containing a bulb, a battery, and a switch. So in this case, we define a simple electric circuit as a closed loop through which electric current flows. And we have 4 main components of an electric circuit. The components of an electric circuit, the first one that we have is a power source. And in this case, the power source that we're going to use is a battery. Then the second thing, the first is a power source. The second component of a simple electric circuit is a conductor. In this case, we're going to use a wire. And then the third thing that it must have is a switch. Then the fourth one that a simple electric circuit must have is what we call a load. In a load, in this case, you can use a bulb. You can even use a resistor and many other components that you can have. So in this case, I want us to draw a very simple electric circuit which contains a bulb, a battery, and a switch, and of course a wire. So in this case, you would draw your conductor like that, and then you can also draw another conductor here. You draw another conductor like that, and then you draw another conductor on this end, but here now it will have a bulb. So this is our bulb. We draw it like that, and then you can continue with this conductor. You can continue with the conductor like this, and then down here we will now have a switch somewhere, and then we will also have a power source on this same line. So in this case we can have our power source, which is a cell or a battery. A battery is drawn like this. Let me connect this one. This is how we draw a battery. It must have this long line which represents a positive, and then a smaller one which represents a negative. And then now from here we will move to a point somewhere there where we will have our switch, and then this switch now is closed. If you close the switch now, the bulb will go on. So apart from drawing this, the other thing that you need to draw is the direction of current. The direction of current always moves from the positive terminal to the negative terminal like that. So you have to draw this for it to be a complete circuit. What you should note here is that the corners of this simple circuit are 90 degrees. They are 90 degrees. That's how we draw conductors in force and energy, that is in physics. So this will mark the end of this lesson. In the next video we will discuss paper 2 of this paper 1.